Hello, this is lesson 93 in Algebra 1. These are the skill problems at the end of the lesson, 11 through 30, working on our basic skills. We're going to start today with some radicals. You remember that it's order of operations, parentheses, exponents, multiply, divide, add, subtract. So we got to start with multiplication here. And multiplication is shown right here. So we got to do that multiplying first. If I do that, 3 times 4 is 12, and 2 times square root of 2 times the square root of 12 is the square root of 24. All right. The other term, 6 times square root of 54, simply comes down, or negative 6 times the square root of 54. Now we are left with a radical reduction problem. And we remember our property. If I have m times n as a radical, I can break it into the radical m times the radical n. So when I look at 24, I want to think to myself, what can this break down to in factors? It helps to think of perfect squares. 4, 9, 16, 25, 36, 49, and so on. 24 is 6 and 4. And these are equivalent, what I've underlined in red. On the other one, square root of 54 is equivalent to 9 times 6. And the nice part about using perfect squares is it makes the next step very easy. If I come down the board, 3 times 6 is the same as square root of 9 times square root of 6. And on the other side, square root of 4 square root of 6 is 2 square root of 6. And these are all equivalent values. We haven't changed the value of the term. Now we do our multiplication, and we end up with 24 square root of 6 minus 18 square root of 6. They are like terms because the radical is the same. I have 24 square root of 6. I take away 18. I'm left with 6 square root of 6. All right, problem 12. Got to multiply here. And again, multiplication is shown right here. Can't do anything here first, so I'm going to distribute first. 3 times 5 is 15. Square root of 2 times square root of 12, square root of 24 again. 3 times 8 is negative 24. Square root of 2 square root of 8 is square root of 16. All right, I'll break the radicals down or reduce them if I can. 24 is 4 and 6. 16, square root of 16 is simply the whole number, 4. Again, I can simplify the square root of 4. Square root of 4 is the whole number 2. If I do 24 times 4, it's 96. And I get 15 times 2, so I get 30 square root of 6 minus 96. And unlike the last problem, this one doesn't have like terms. Can't combine these, and that is the solution. Problem 13 and 14 are polynomial division. Our first step is to set it up as division, and to make sure it's in descending power. And this time for 13, it is. All right? And it works just like longhand division. What times x did you execute? X squared. We have to take x squared times the whole quantity right here. This whole thing has to be multiplied. So we do x squared times x minus 3, and I'm left with x cubed minus 3x squared. All right, we have to subtract, but we don't subtract. We change the signs and add, and I get 0, and I get 0. So then we have to bring down the terms. 2x plus 5. And I could bring the 0 down, but I don't need to show that. All right? So I have 2x plus 5 here. Now the question is what times x gives you 2x? Well, how about plus 2? And I suppose that could be shifted a little bit further over. So it's 2 times x minus 3, and I'm given 2x minus 6. All right, again, we have to subtract, but we don't subtract. We change the signs and add, and I'm left with 11. That becomes my remainder, plus 11 over x minus 3. Now we got to talk a little bit about how do I check this. I want to be sure I'm right. Well, just like this problem, 2 goes into 8 4 times. I checked this because 2 times 4 is 8. So just like that, I know x minus 3 quantity times x squared plus 2 plus 11 over x minus 3 has to be what's underneath the bracket. So I will do this multiplication. And one trick here is that I can do, instead of doing both parts separately like this, I can do this. X minus 3 times all 3. And you'll see why you want to do it this way. So I get x squared times x minus 3 plus 2 times x minus 3 plus 11 over x minus 3 times x minus 3. And the reason to do it this way is on the last term, the x minus 3s are going to cancel off the remainder, making your life a little bit easier. I'll have to distribute again, though. I combine like terms on the end there. The last 2 terms can be combined. I get x cubed minus 3x squared plus 2x plus 5. If I go back up the board and check, it is the same. And I've done a good double check. On problem 14, we have to set it up again and make sure it's in descending power. I'm going to leave some space. And it works the same. So we say, what times x gives you x cubed? And it's x squared again. Green this time. X squared times x plus 3. When I distribute this, I get x cubed plus 3x squared. We have to subtract, but we don't subtract. We change the signs and we add. X cubes cancel. You'll notice these are not like terms. So we can't combine those. All right? So we just have to write all the stuff that's left in descending power. And now it's time to rinse and repeat. What times x gives you negative 3x squared? Oh, minus 3x. And again, we have to take minus 3x times the quantity, x plus 3. We distribute. Again, we have to subtract. We change the signs and add. When I change the signs and add, these cancel, and I'm left with 9x minus 1. Again, these are not like terms, so you can't combine them. So what times x give you 9x? How about plus 9? 9 times x plus 3. I get 9x plus 27. I don't subtract. I change the signs and add, and I get negative 28. That becomes the remainder up on top. Again, to do a double check, I can take x plus 3 times the answer I got to make sure that this is correct. X squared minus 3x plus 9 minus 28 over x plus 3. If I have any math mistakes, they're going to show up right now. Again, I will take the whole quantity and distribute it 4 times. Now I'll get x squared times x plus 3. I will get negative 3x times x plus 3. I will get plus 9 times x plus 3. And I will get minus 28 over x plus 3 times x plus 3. And we do this way so that these 2 on the end cancel. I'll redistribute here. X cubed plus 3x squared minus 3x squared minus 9x plus 9x plus 27 minus 28. Combine like terms. These cancel. Like terms. These cancel. I'm left with x cubed minus 1, which is the same. Which means my answer at the top was correct. All right. So number 15 is solve by factoring. Again, you look at this problem and you see that it is a polynomial with order 2. So again, immediately you know that there's going to be 2 answers. All right? When I look at this, I always start by saying what's common and what can be pulled on. And I am sort of ignoring the 0 at this point. Nothing comes out. So since it's a trinomial, I hope it will factor. X times x is x squared. I think of the factors of 20. 1 and 20. 2 and 10, 4 and 5. And I'm looking, since the coefficient on these binomials is 1, I can think to myself, what is the sum of these? 21 or 19? Not negative 9. 12 or 8? Not 9. How about 4 and 5? They make 9. Both signs will have to be the same, negative 4, negative 5. And now I'm done ignoring that this equals 0. This still equals 0. And now we have our very special property for 0. We know P times Q, when it equals 0, either P is 0 and or Q is 0. Well, that's our property here we're going to use, all right? So I can set x minus 4 equal to 0, the P, the 4, and the Q. And again, very easy equations. The answers to this problem are 4 and 5. And if I want to check them, I can go back to my original problem, replacing x with parentheses, and plug in the 4. 16 minus 36 plus 20 equals 0. Yep, that one works. Replace the 4 with a 5. I'll do it red. Quickly do the math. 25 minus 45 plus 20 equals 0. The answer is yep. Both answers work. That is the correct problem. We're going to jump to 16. 16 has a problem. For us to solve by factoring, it has to equal 0. And this doesn't. So we got to get all the terms to one side. And I see a negative x squared. So I want to move x squared to the other side. And if I do it in 2 steps, just to make it a little more clear, I can do this. And then I got to get the 13x over here too. And I want x squared to be positive, guys. It might have been easier to move the 42, but our goal has to be to have a positive x squared. Again, so when I see this, I can quickly see that this is also factorable. And I see, again, that nothing common. There's nothing that can factor out initially. There's nothing common. So it's a trinomial. I'll make it into a binomials that are multiplied. Again, P times Q. And I get answers of 7. And answer of, whoops, x is 7. And x is 6. And there has to be 2 answers because it was x squared. Last one for this 15-minute section, 17. Again, 17 can be factored. You can always factor the difference of 2 terms. You can always factor those. So, if I can factor them, we take the square root, and they're the conjugates of each other. And again, that'll become a real important word when we get to algebra 2. And again, since it's 2 terms, we just take the square roots, the conjugates of each other. And again, you have to set each of these equal to 0. And if you solve these, opposite side, opposite sign, I get negative 3/2, and I get positive 3/2. And again, if I want to check those answers, I didn't check the last one, let's check this one, just to be sure. I'll go with 3/2 squared minus 9 equals 0. I get 4 times 9/4, right? When you square 3/2, 3/2 times 3/2, I get 9 minus 9, and we all know that is 0. And we know also that if I put the sign in here, it's still positive. So both answers work.